Good morning. So this lesson is starting chapter 1 of Algebra 1, and our first lesson is on evaluating expressions. So to evaluate algebraic expressions, and we're also going to use exponents within those as well. So a little bit of vocabulary review here. We have a variable. So a variable is a letter used to represent one or more numbers. So any number that you don't know can be substituted with a variable to represent that number. An algebraic expression, or sometimes it's known as a variable expression, consists of numbers, variables, and operations. When we talk about operations, we're talking about addition signs, subtraction signs, multiplication, division, those things. Not equal signs, though. Once we introduce an equal sign in there, that becomes an equation, and that's not the same thing as an expression. To evaluate an expression. So we evaluate an expression, we don't solve an expression. So to evaluate an expression, we're going to substitute the number that's given to us for the variable and then perform those operations, whether it be multiplication, addition, or whatever the problem is indicating. Then we have powers. A power is an expression that represents repeated multiplication of the same factor. So that would mean if you had 2 times 2 times 2 times 2, we could write that as a power 2 to the fourth power, indicating that the 2 will be multiplied by itself 4 times. So for example, 2 times 2 times 2 times 2 could be rewritten as 2 to the fourth, and that would be now a power. A power can be written in this form using the base number. In this case, the 2 would be the base number, and this 4 here would be the exponent representing the number of times that the base number would be used as a factor. So the first example we're going to do here is evaluating some algebraic expressions. So when we evaluate these expressions, we are basically going to substitute something in. So in the directions here, we're substituting in 5 anywhere we see the variable x. So for this first one, now whenever you have a number and a variable next to each other with no sign visible in between them, that indicates that there's multiplication happening. Now you can write a multiplication sign, or you can also use parentheses anytime you substitute something in. So when we're in algebra, we typically use parentheses around whatever number was substituted in for a variable. And when the parentheses are next to something, that indicates you're going to multiply those two numbers. So in this case, 7 times 5 would then equal 35. So example B, we have 12 plus, and then I'm going to put my 5 in here. Now I didn't put parentheses around it because I already have an addition sign there telling me what I'm going to do. But even if you did put them there, it wouldn't change anything because there's no number in front of the parentheses there to multiply to. So it would just be 12 plus 5, which of course is 17. Now for example C, we have -4, and we're substituting in the 5 for the variable x. Again, this parenthesis here with the number right next to it is indicating that this is going to be a multiplication. And we have a negative here. So we're multiplying a -4, the positive 5, which is going to give us -20. Example D, we have an 8 on the top of that fraction, and we're substituting in the 5 on the bottom. Now in this case, the fraction bar, you might remember, also indicates division. But if you do 8 divided by 5, you would get, I believe, let's see, it's 1.6. If you left it as a fraction, that would actually also be okay. So in algebra, generally speaking, we're allowed to leave improper fractions as our answers, as long as it's not a word problem where maybe you're talking about specific number of items. You wouldn't say you have 8/5 of something. So in that case, you might need to use a mixed number, which 5 goes into 8 once with a remainder of 3. And then you put that over that bottom number of 5. So any of those 3 answers would be okay. It just depends on the situation, which one would be preferred. So let's just practice a few more of those. If you're watching this video, this might be a good time to pause the video, do these 3 problems, and then turn it back on and check and see if you got them correct. So for number 1, 15 minus 3, which of course is just 12. For number 2, 3 times 7, you're substituting in that 7 for the b, which is 21. And number 3, we're going to substitute in the 10 for the c, and that is also 21. Okay, a few more of these. Same thing, might be advisable for you to pause, do them real quick, and then press play again and see if you're getting them correct. 28 divided by 4, which is going to be 7. Here we have 1/2 times 18. Now, if you're multiplying 18 by 1/2, you're just saying, well, what's half of 18, which is 9, just like division. 0.4 times 8. Now, this is a situation where you might have trouble doing that in your head. Now, I know 4 times 8 is 32, and since I have that one decimal there, I know it's going to be 3.2. But if you're a little bit, get a little bit tricky with the decimals, you're just multiply it on your calculator, 0.4 times 8, and you would get that 3.2. Okay, number 7, 6 times 2, which is 12. Number 8, 11 minus -1. And notice this time I put the parentheses around the -1. That's because we would be subtracting and negative. When you have two signs in a row, that's not usually something we like to see. And hopefully you remember that when you subtract a negative, that changes it to addition. So we're really adding positive, but I don't need to write +1. It's implied if you don't see it in front of it. And that, of course, is also 12. And then finally, our last evaluating problem here, the z plus 4. We're substituting in the -3 plus 4, -3 plus 4. Since they have different signs here, it's really like subtraction or finding the difference, and that answer is just going to be +1. So let's take a look at this word problem here. The cost of filling a car's gas tank can be represented by the expression x, y, or x times y, where x is the price per gallon of gas and y is the number of gallons purchased. So we're going to take those two things and just multiply them together. So the price per gallon is $2.35, and then we know that the number of gallons purchased is 10. So we're going to multiply those two things together. So we're going to take the 235, and that's going to be substituted in for the x. And then we're going to take the 10, and we're substituting that in for the y. And then we're multiplying those together. Now, of course, anytime you multiply a decimal by just 10, however many zeros you have, that's essentially how many times you're going to move that decimal point over. So this is just going to become $23.50. And you could always check it on a calculator if you need to. So let's try the next two. Just practice it. It's just going to have a couple, some different numbers for you to substitute in this time for the variable. So we're still using x times y here, or multiplying the two together. So you purchase 5 gallons, and the cost is $2.26 per gallon. And over here, you're doing 220 times 8. So if you do this on your calculator, $2.26 times 5, you're going to get $11.30. Make sure, because this is a money problem, that you put your dollar sign on there. It's appropriate label. Instead of writing 11.3, you would want to make it dollars and cents. That's why I'm putting 0.30, because it has to represent an actual dollar and cent amount. 220 times 8. Again, if you need to, use your calculator. So $2.20 times 8 is $17.60. Again, making sure I put that 0 on there since we're talking about money, and I put my dollar sign. Okay. The next example we're going to talk about is reading and writing powers. So we talked about that a little bit in the vocabulary section in the beginning. So the two things that we're going to do is we're going to write the power in words, and then we're going to write it as a product. So just writing it in words is like, how would I say it to you, right? So for this first one, you would say 8 raised to the third power. Okay, that's one way you could write it. This one also has a second option. Anytime something is raised to the third power, you might have heard of something being cubed. So you could also say 8 cubed. Now, if we take a look at example B, this time we have a variable instead of a number. So instead of saying 8 and spelling it out, sometimes people will say a number m, but in this case, I'm just going to say m raised to the sixth power. Okay, for C, now this one could be a little tricky. You have a 7 raised to the first power. That's all it is. It's not any more confusing than that. It just is kind of weird. It's actually a little bit trickier as a product. So 7 raised to the first power. Now, if I were to write these out as products, that's what's being multiplied. So for A, it's going to be 8 times 8 times 8, or 8 multiplied by itself 3 times. For B, we have M times M times M times M times M times M, or M multiplied by itself 6 times. And for C, this one can get a little tricky. You're taking the 7 and you're multiplying it by itself once, which just means you just have a 7. So sometimes people think it's going to be 7 times 7 because it's being multiplied by itself, but it's just the 1 7, so you don't have to do anything else. Now, if you took a look at D, for example, 5 to the second power there, that would be where you do 5 times 5. Or an example here with E, we have 1/2 times 1/2 times 1/2. Or for example, F, Z times Z times Z times Z times Z. Now, as far as writing these out in words, the 5 to the second power here, of course, we could write 5 raised to the second power. But this is one of those special ones because the second power is also known as something being squared. So we could also write that out as 5 squared. So whenever something is being raised to the second or third power, it also could go by those other options as being squared or cubed. So E here, you would say 1/2 cubed if you'd like. It's a little bit shorter. Or you can say 1/2 raised to the third power. And then finally, the last one here, this variable 1 is just Z raised to the fifth power. Okay. So beneath that, there's some examples that you could do on your own, but I think after those 6, you should be okay. So I'll let you kind of do that on your own. Okay, so then the last part here, we're evaluating the expression just like we did in the beginning of the lesson, but now we're also going to have some of these powers integrated in that we're going to work out. So this is where parentheses become a little bit more important when we're substituting values in. So we saw in the beginning when we were maybe adding or subtracting, it wasn't as important for us to put those parentheses in, but whenever you're multiplying or you have powers, it's always a good idea to use parentheses, even if you might not need them. It can never hurt to write it out with the parentheses. And in some cases, particularly when there's negative numbers, you're going to need them or your answer will be wrong. So here we're substituting in the 2. So I'm going to do 2 raised to the fourth power. So remember, this is really 2 times 2 times 2 times 2, which will equal 16. Now, this one wasn't too bad. You could do it without a calculator, right? Especially if you write it out like this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. But if you have higher numbers, it's going to be a little bit trickier to do in your head, right? So you're going to have to use calculator. So if I have my calculator and I want to raise it to a power, now this is a graphing calculator here, TI-84 plus CE, which is the one that I would recommend if you were going to purchase one. You would do 2, and then this little button, and scientific calculators have this as well. This looks like a triangle without a bottom on it here. That's what it looks like on my calculator. That's the raised key. So anytime you need to put an exponent on a number, this would also be found on your scientific calculator as well. And then we're going to put a 4 there because we're raising it to the 4th power. And then I'm going to hit enter or equal. And I get my 16. So let's take a look at the next one. This time we're putting in a decimal value. So this is where you're probably really going to want to test out the calculator for this one. Last one you could probably do in your head without the calculator. This one's a decimal. It'll be a little bit trickier. So 1.5 to the 3rd power. So I'm going to use parentheses. Now technically you don't need them for this problem, but if it were a negative 1.5 you would have to have them. So that's why I'm just doing that. I'm raising it again with that little button there, and then I'm going to raise it to the 3rd power and hit equals 3.375. And then finally, the last one, we're putting in a fraction this time. So we're going to do 1/3 to the 4th power. Now there's 2 ways of thinking of this. One of the ways is 1/3 times 1/3 times 1/3 times 1/3, right? Now, if you remember all your rules for multiplying fractions back from middle school or whatnot, you would multiply all the numbers on the top. So 1 times 1 times 1 times 1 times 1 is 1. And then here, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So our answer is going to be 1/81. But a little bit quicker of an option would just be to do 1 to the 4th power, which would be 1, and then 3 to the 4th power, and then that would give you your 81 on the calculator. So a couple ways you can get that answer. All right, so a couple examples for those. Again, it might be a good idea to try doing them on your own and then check your answers. Otherwise, I'm just going to go through them. So we have 8 to the 3rd power. So 8 times 8 times 8, or you could just do it on your calculator as 8 to the 3rd power, and that's going to be 512. Here we have 2.5 to the 2nd power. So again, on our calculator, 2.5. Now I can raise it to the 2nd using that little caret key and a 2, or most calculators have a squared button since it's so frequently used. Mine is over here on the left. It says x squared, and that's another shortcut. So I don't have to hit the caret and the number. I can just hit the x squared. And most calculators will have a shortcut for that as well. And again, it's still 6.25. Okay, then n to the 5th when n is 3. So we're doing 3 to the 5th power. So 3 raised to 5. If you put it in parentheses, you get the same thing, 243. Okay, so now here's another one of these fractional ones. So we have 2/5 to the 2nd power. Now that's really just 2/5 times itself 2 times, right? So for me, 2 times 2 is 4, 5 times 5 is 25. I can do that pretty quickly without a calculator. If you needed to do it on a calculator, you would have to use those parentheses. So 2/5. So watch what I'm going to do. Parenthesis, 2 divided by 5, parenthesis, raise that to 2 or hit the squared button. And there's my answer. Now, a lot of calculators give you the answer as a decimal. If you have the fraction, if you have the graphing calculator, if you do math, and the first thing that pops up is this fraction conversion here, and I just hit enter, it will convert that to that fraction. Okay, next one, we have 5 to the 3rd power, which is going to be 125. And then here we're going to have 7 to the 2nd power, which is 49. And that's it for today's lesson.